Greetings everyone, this is Non-Expert here, back again with another video. Today we are going to be solving problem number 52 and the difficulty it's been rated at is hard. This problem was asked by Google and let's just get down to the problem description. So we need to implement an LRU cache or a least recently used cache. It should be initialized with a cache size of n and it should contain the following methods: a set method which has two parameters, a key and a value, which basically sets the key to a value. And if there are already n items and the n which we are talking about over here is the cache size n, if there are already n items in the cache and we're adding a new item, then it should also remove the least recently used item. And we need to implement a get function as well, which takes in a key parameter, which basically returns the value associated with that key. And if no such key exists, we need to return none. One of the most important thing is that each operation over here or each method that we have over here should ideally run at a time complexity of O of 1. Now, whenever you sort of get a question like this, when you want to, or at least want to try to, solve things with a time complexity of O of 1, the first thing that you think of are hash maps. But before I get into that, I want to tell you that this question is actually pretty popular, and most interviewers would actually ask you this question just because they would expect you to understand, or at least have a general understanding of what a cache is and how it's used, and just try to build it out. If you don't know what a cache is, in the most simplistic terms, you can just think about it as a data store which is generally used to reduce duplicate network calls or any call. Um, so again, if you don't know what it is, I would suggest that you read up on it. I'm not really doing it a lot of justice by explaining it in one line, but it's a very popular approach, and one of the most common implementations of a cache is a LRU implementation. And fortunately, today we were able to find a similar problem on LeetCode, and the name of the problem is LRU cache. And again, as usual, I would urge you to pause this video and check out the link given in the description below and try solving this problem on your own. So you can sort of pause this video and check out the entire problem description over here. It's the exact same thing. Um, and the way they want us to implement this is by basically, filling out the methods which have been given in the LRU cache class. But before we get into that, I just want you to understand a few things about LRU. Most of you would already understand what it is, but just for sake of getting more clarity, let's just take a simple example. Let's just say that you have a stream of elements, and I'm just taking a stream of elements over here, and we know for a fact that the put function which we have is going to have a key and a value. So whatever is the element over here, that's the key as well as the value. So, and let's just take for our case that the capacity or n, as given in daily coding problem, is 3. So the capacity of our cache is just 3 elements. So what you want to do in this case is the fact that you want to maintain two things. First thing that you want to maintain is a dictionary or a hash map, which is pretty obvious, just because you want to perform searches at the O of 1 complexity. And the other thing that you want to take care of is the order. And the way you can sort of do that is by maintaining a list. And inside the list, what you would want to do is that each element that you have could basically be the key. That will sort of help us out to just understand that which element is getting popped out, which element is big inside, and just manipulate all those things. So whenever we pop out something, we know for a fact that whatever is being popped out, it's sort of the key which is getting popped out. We would sort of always have the key, and we can sort of delete that value from the cache itself. But more on that later. So let's just sort of look at this example. So the way this would work is, and all of these are just put operations. So the way you would sort of put this is just 1 over here. And obviously inside a dictionary you would have 1 comma 1 because we're just taking the key and the value as whatever the element has been provided to us. Then what you're doing is you're just appending into the values. So you're just doing append. So the next value which comes in is 2. So you append the same thing inside your list, which is 2. And you sort of update your dictionary accordingly. And then you have 3. So the same exact logic, 3. And then you sort of update the hash map as well. Now, one thing to note over here is that by maintaining this or sort of appending the values as you sort of use them, what you're doing is that you're sort of maintaining an order, and the order is based on whatever is being least recently used. So whatever value is on the leftmost side or the leftmost element of the first element inside the order list is the element which has been least recently used. So in our case, when we encounter 4 and we append 4, um, and sort of go ahead with the dictionary implementation as well. So when we would have to consider the case of uh, handling the capacity or the overflow condition where the size is actually greater than the capacity which has been given. So all you have to do in that case is that you want to pop out the least recently used element, and the least recently used element that we know for a fact that's the leftmost element, so we will just pop that out. And as soon as we pop that out, we would know for a fact that what's the key. So the key over here was 1 comma 1, so we can pop that out as well from the dictionary. I hope this makes sense, and when we sort of code this out, it will become more clearer. But one thing which is actually more important for us to understand is that we sort of define what do you mean by recently used. Um, for most definitions, recently used means that whenever you do a get operation or put operation, that particular value has been used. So let's just take for clarity's sake that somewhere over here there was a get call. So let's just say there was a get call of 2. So what would happen in this case is that you would sort of get this value in an O of 1 complexity, and actually we'll sort of get into the O of 1 complexity in theoretical sense as well. But yeah, you would sort of hit this value because you're just matching the key, and you have an associated value with it. But what's more important is that since this already belongs here and you're doing a get operation, you need to pop out this particular value, and you need to sort of place this in front because now the least recent or the recently used value, the most recently used value is 2. So again, since we're maintaining the order, the left hand side would be the least recently used value, which is 3, which has not been used, and 2 would be the most recently used value. And that's just something that you want to take care of, but yeah, we'll be getting into that as well. So let's just declare a few variables, and obviously we need a capacity variable to just understand what our capacity of our cache is. And now we'll just call a cache. This is basically our dictionary, and we need an order list. Now we'll implement the get function in a while. Let's implement the put function first. So the way the put function works is that you want to take care of whether the value already exists, and that's your base condition. So if the value already exists inside your cache, it obviously exists inside the order as well. So you need to remove that value because that value is because it's completely irrelevant, right? So think of it like this: that you're making a network call, and when you make a network call, data that you're getting or you were previously getting, that value is old data, and you want to update it accordingly. So just for that reason and just for maintaining the order as well, you sort of need to pop it out and append it again. But let's just go with the simple implementation first. So we'll just say, hey, self.cache key is basically equal to the value which has been provided to us in our parameter. And inside the order list, we just need to do a simple append. And we're appending the keys. Do remember this, that's actually important. We're appending the keys. And we can sort of handle the base condition as well. So the base condition over here is that, hey, if the key is already in self.cache, we need to remove it from self.cache as well as self.order. So this thing is actually overriding the value, so we don't need to remove that, but self.order needs to get updated as well. So we need to remove it, and we'll just say self.order.remove. Python has a remove function. If you didn't know, it basically takes in a parameter and sort of traverses through the entire list and looks for that particular element and just pops out that element. So you've maintained that. Now the only thing which is left is that you want to handle the overflow condition, and that's very easy to do because you have a self.order list, and you can just compare the length of the self.order list with the self.capacity, or the capacity of the cache which was initially given to us. So if it is actually greater than that, so what we have to do is we have to remove the least recently used value. And whatever value that we're removing, we need to use its key and delete that value from the cache as well. So let's just do that. Let's just call popped key. And basically we can do self.order.pop and pass in 0. So what this is going to do is this is going to remove the leftmost value. And now the next thing that we sort of want to take care of is that we want to update the cache as well. So all you have to do is you just have to reference the cache and just say self cache and remove whatever was the popped key. So let's just do that, and that's basically our entire put operation. Now let's get down to the get operation. Get operation is very simple. So you just have to check for base condition first. The base condition is that if the key does not exist inside self.cache, you want to return -1 or none. But if it does exist inside the cache, you want to update the order as well. So the way you can do that is that you can sort of use the remove function, remove the key, and then append it again. So basically what's going to happen is that that remove is going to remove that element, and then the append is going to append it to the last. So let's just do that. Let's just do self.order.remove key, and then when it's been removed, we just do an append. And in the end, what we want to do is we want to return cache, the value which has been associated with the key value, right? So we're maintaining the order, but we're also returning the cache, and that's basically it. There's not much here to do. Let's just try running this once. Hopefully this should run. And awesome, you can see that's running. Let's just try submitting this. And you can see it's getting submitted, but it's not the most fastest solution. And you can actually see the reason behind it is that you're using a remove function and a pop function. And both these guys are actually working at a complexity of O of n. The reason why self.order.pop works at a complexity of O of n is basically that whenever you remove the first element, all the other elements which are there inside your array, they also need to get shifted one position behind. And that needs to happen for all the operations. Your address is not going to get updated accordingly. So that's an O of n operation, and you can update that by using something called as a dequeue. I've mentioned this in one of my previous videos, but that would still not handle the remove, because the remove is still going to iterate through the entire list and then try to look for that element, and whenever it finds that element, it's going to remove it. So that is also going to be an O of n operation. So one way to sort of take care of this is actually by using something called as an ordered dictionary. You can implement an ordered dictionary on your own as well. It's pretty simple. It has the same concept as well, that you have a dictionary, but instead of just having a simple key value pair, what you could have is you could have a key value pair, but also you could have that as just your data, and then you could have a particular value called as index, which could just store which index has this value been stored into. So you could reference that, you could just call that and then call it accordingly. But you would also have to maintain a list just because of the entire operation, because you would still want to understand, whenever this overflow condition happens, you would still want to understand which was the least recently used value. And the way you would want to do that is still contain a list. But now instead of just iterating through an entire list, you would already understand that this value already exists over here. But again, there's a few complexities over there. I'm not going to get into that, but today what we're going to do is we're going to use something called as an ordered dict. And ordered dictionary is basically a dictionary which has a particular order. Now, most of you would not actually know this, but whenever you implement a hash map, or actually most of you would know this, whenever you implement a hash map, it uses something called as a hash function to assign where the values go. And all these hash function, the values, the way they sort of get processed and all those things, that sort of does not help us, maintain the order in which each element has been pushed inside your hash map. But inside an order dictionary, you can actually maintain it. And again, the way to implement this is by using a module called collections, and we'll just import ordered um, dict. Um, and this is sort of help us, remove the order list. We don't need it. Let's just call this as ordered dict. So basically, we're just going to have self.cache, which is going to be our dictionary, and all the appending and all those things that we are doing inside our self.order, all of those things just sort of go out of the window. But you can still reference self.cache as the way you sort of reference it with your key values, just like a normal dictionary. Uh, but this thing is actually very easy to do. But what you want to do is you would still use the same logic that you would delete the element and then append it again. And just if you do that, the order is still maintained. So we're going to be leveraging the same, uh, use case that we were using or implementation that we were using. So let's just call, or let's just make a value which was the value of the key or the associated value to the key. And now what we want to do is you want to remove self.cache key. And when it's been removed, all you want to do is you just want to, update it again. So if you do that, the order is sort of still maintained inside your order dictionary. So what you're doing is inside your order dictionary, you're removing the value, or you're sort of saving the value first, then removing it, um, then setting it again, and just referencing it or returning it back. That's just the get operation. It's pretty simple. A similar approach sort of applies to the put function as well. So as you could see, you were sort of searching for, if the key already exists inside your self.cache, what would you do in that scenario? So again, the scenario is the same. You just sort of, I'm just going to copy paste this. You can just remove this particular value, and just move on from there, right? So self.order is no longer required. You're updating self.cache key value pairs being updated. And over here, what you could do is you could just update this self.order to self.cache, because order dictionary also has a length method which returns the length. And over here, what's more important is that you can sort of leverage something called as a pop item. And a pop item method is basically a method which has been given in an order dictionary. And what it does is it pops out uh, a particular item or whatever item that you recently given. So all we have to do here, we just have to remove the least recently used value, and this is by saying self.cache pop item and just give false as a parameter, just so that it removes the first value. And that's basically it. So let's just try running this again. And awesome, you can see it's running. Let's just try submitting it. And hopefully it should get submitted at a better complexity. And you can see that's running faster than 75% of the Python online submissions. And the entire implementation of order dictionary also sort of works on a premise of an O of 1 complexity. So you're sort of managing that as well, and you're taking care of everything else. It's not the most memory efficient solution, and the reason for that is just because you're using an order dictionary. And if you don't know what an order dictionary is, I'll just sort of explain it again. Yeah, it's just that it's a simple dictionary which sort of maintains the insertion order as well. The entire implementation of an order dictionary sort of relies on the fact that it wants to use the same signature of that of a dictionary, and it does use a dictionary. But also by using a dictionary, it also implements the way we sort of maintained our ordered list. It also maintains something called as a doubly linked list. And the reason why that is just because, as you would sort of see in our approach as well, whenever we were doing a remove, even if we would do a simple pop and simple pop left, that entire operation would be an operation which would run at a complexity of O of n. Whereas when you sort of do that in a doubly linked list, you're just popping out one element, and that's basically it. You don't really worry about all the other references, because the pointers of that reference sort of, get updated accordingly. And that's like the entire approach of a set item or a get item, and those are basically the methods which are sort of implemented inside an order dictionary. If you want more clarification or you want to check out the code, I'll sort of leave it in the description and you can check it out on your own. But all in all, it's sort of using a simple dictionary which sort of works in conjunction to a doubly linked list, and they just sort of go hand in hand, and it sort of uses a simple approach of understanding which element was first element which was entered, which was last element which was entered, and goes on from there. And the similar thing that we sort of talking about, the pop item function that we sort of use, it sort of uses the same thing, which sort of just tries to understand whether it needs to pop out an element based on a LIFO approach or a FIFO approach. And again, you can sort of check it all out in the description below. I would sort of leave the link there, and you can check it out on your own. And that's basically it. Cool. So if you have any comments or if there's something that you do not understand, you do leave it in the comment section below. I would love to handle any of your queries. And if you did like this video, do give a like and do subscribe to this channel. We have discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it. And have an awesome day. Thank you.